Thanks for watching my video. In the last video we proved about the integral of sine hyperbolic and cos hyperbolic, right? So now let's discuss about tan hyperbolic. And okay, so this I name it as number 3. Now we are going to integrate tan hyperbolic of ax dx, which is nothing but 1 upon a natural log of cos hyperbolic of ax plus constant of integration. Okay, now here we go, let's prove it. Now let's score I to be the integral of tan hyperbolic of ax dx, right? And we know that tan hyperbolic of x is nothing but sine hyperbolic of x upon cos hyperbolic of x. Okay, now we apply that one. And what will be all next now? So our I is going to be, in place of tan hyperbolic of ax, so sine hyperbolic of x upon cos hyperbolic of x dx. Now let's use some substitution method. Okay, now let me put ax to be u, so which is nothing but, if you differentiate is a dx equal to du, so dx is going to be 1 upon a du, right? Now our new substitution will be u, right? Now I is going to be sine hyperbolic of u upon cos hyperbolic of u, and in place of dx 1 upon a du, right? So this one, which is equal to 1 over a is nothing but just a constant. Okay, so coming out, and integration of sine hyperbolic of u upon cos hyperbolic of u du. And if you see that the one that I proved, the derivative of hyperbolic function, okay, you will see there. Now I is going to be 1 upon a, the integral of sine hyperbolic of u is nothing but cos hyperbolic of differentiation of cos hyperbolic. Okay, so cos hyperbolic dash of u upon cos hyperbolic of u. This is nothing but differentiation. Okay, differentiation one time. Now if you differentiate cos hyperbolic of u, then you'll get sine hyperbolic of u. Okay, so and what is this? This is, we applied here one technique of integration. Okay, which, so this one, so if you integrate a function, okay, and the derivative of a function is in the numerator, then our integration will be natural log of our function, okay, f of x, right? This is something like integration by part or integration by substitution. Okay, maybe one of them. Okay, so you will see that proof. Okay, I have already done that. So this will be 1 over a natural log of cos hyperbolic of u, right? So this one, which is 1 over a natural log of, so we are not in the u world, right? We are not in the u, so our original is what? We are in the x world, right? So in place of u, just substitute back. Okay, what is that? U equal to ax, right? So 1 upon a natural log of cos hyperbolic of u, in place of u, ax, right? So this is what we are to prove, right? So our integral tan hyperbolic of ax dx is nothing but 1 upon a natural log of cos hyperbolic of ax plus c. Okay, so this is all proof for this integral. Okay, now next let's see for tan hyperbolic, right? For tan hyperbolic, cot hyperbolic. Okay, so the integral of cot hyperbolic of ax dx is nothing but 1 upon a natural log of sine hyperbolic of ax plus constant of integration. So if you compare these two, if you integrate cot, you get natural log of sine, right? And tan is natural log of cos. Okay, you are just differ by that only. Now our I is going to be this one, natural log of integration of cot hyperbolic of ax dx. Cot hyperbolic of x is nothing but cos by sine, right? So I is going to be cos hyperbolic of x upon sine hyperbolic of x dx. Now substitution method, ax equal to u, so differentiate it, a dx equal to du, so dx is going to be 1 upon a du, right? So I is going to be integration of cos hyperbolic of u upon sine hyperbolic of u, and in place of dx 1 upon a du, right? Du 1 over a, and a is nothing but constant, so coming out in the front 1 over a, and cos hyperbolic of integration of cos hyperbolic of u upon sine hyperbolic of u du. Now if you see the integration by differentiation of hyperbolic function of sine, okay, you will see that in there. You will see here I is going to be 1 upon a, integration of, in place of cos hyperbolic of u, I can put differentiation of sine hyperbolic of u, right, upon sine hyperbolic of u du, because if you differentiate sine hyperbolic of u, you will get cos hyperbolic of u. Okay, now from technique of integration, if you integrate a function whose derivative is in the numerator, then you'll get natural log of f of x, right? So I is going to be 1 upon a, natural log of sine hyperbolic of u. So we don't want u, right? So we are in x, right? So just substitute back. So what is u? Ax, right? 1 upon a, natural log of sine hyperbolic of ax. So our integral is cot hyperbolic of ax is 1 upon a, natural log of sine hyperbolic of ax plus the constant of integration. Always remember that in this case, always a is greater than 0. Okay, this is the main point. Okay, and thanks for watching my video.